Okay, good morning. We are going to have an example of the graphical method, specifically head to tail. Okay, so we are given three vectors, D1, 25 meters east, D2, 30 meters north, D3 is 10 meters at 30 degrees north of west. Okay, so the first thing that you have to do is to choose an appropriate scale. So the scale will depend on on your choice. Okay, so let us choose that all 5 meters will be represented by 10 millimeters in your ruler. Okay. After you have chosen a convenient scale, we now uh, get the equivalent values of D1, D2, and D3. Okay. So D1 is, let's say, 25 meters. Okay. So 5 meters, 10 millimeters. This one will give us 50 millimeters. D2, 30 meters. This will give us 60 millimeters. Okay. And D3, which is 10 meters. Okay, this one will give us 20 millimeters. Okay, so after we have solved for the following, it is now the next step would be to choose, the next step would be to estimate where these vectors are heading, okay, based on the direction. So it says here D1 is first heading east. So let's estimate. This is important so that you will know where to start in your blank sheet, okay? So uh, D1 heads east first, and then D2 heads north, and then after some time, um, on the third vector, 30 degrees north of east. So somehow, your vector, okay, these three vectors would go in this direction, okay? So this is our resultant. So I did not measure these estimates yet. Okay, this is important only so that we would know where to start in your paper. Okay, so since we know that this is the direction, let's start at the lower part. Okay, so the first thing that you have to draw is 50 millimeters. Okay, so 50 millimeters east. Okay, so let's start with this point, 50 millimeters east. So it's heading east. So this is 50 millimeters east. Let's name this as D1. And then the next vector is D2, 60 millimeters north. Okay, so we draw D2. North is upward. So we have to draw it upward. Okay, let me show this. And it says here 60 millimeters. All right, this is 60 millimeters north. Let's name this as D2. The next vector is 20 millimeters at 30 degrees north of west. Okay, so this is different from D1, D2 because D1 and D2, they lie on the axis. So in this case, for D3, you have to draw first an imaginary Cartesian plane. Okay, so let us draw the imaginary Cartesian plane. This is our x-axis, and this is our y-axis. The imaginary Cartesian plane will help you know where to place your protractor. Okay, so we place your protractor here at the origin, and it says there 30 degrees north of east. So coming from the east, here, it's in the second quadrant, so 30 degrees. This is 30 degrees. Sorry, this is 30 degrees. Okay, and then from here, we measure 20 millimeters. 20 millimeters. So this is 20 millimeters. Okay, so 0 to 20 millimeters. Then we put the arrowhead. Now, we already have the three vectors represented, drawn to scale. The last step is to connect, okay, where you started up to where you ended. Okay, so we connect this. You can choose a different colored pen. Okay. This is our resultant vector. Ayan. Then, using your ruler, what is the measurement that you read? Okay, from where I am right now, I can see that this is 77 millimeters. Okay, 77 millimeters. So I write 77 millimeters. Okay, 77 millimeters. And then I scale back. Okay, I scale back 2 meters. So 10 millimeters is 5 meters. Okay, using your calculator, 77 times 5 divided by 10, you will get 38.5 meters. Okay, assuming that this is two significant figures, your answer will be 39 meters. Okay, now what we have right now is just the magnitude. How do we get the direction? So we put the protractor at the starting point here. Okay, we put the protractor here. Okay, so, and then we measure that this is 63 degrees. Okay, so 60 degrees. So we put here 39 meters at 63 degrees north of west. Okay, this is 63 degrees. Please try this one out at home with the same set of examples. Okay, thank you.